Have you ever come across a video, maybe an article, outlining 7 distinct levels of artificial intelligence?
Oh, yeah, definitely. They seem to pop up quite a bit online.
We saw one too, and it really made us want to dig a bit deeper. Because, well, it turns out the idea of exactly 7 scientifically validated steps for AI, it's more of a popular concept than a hard and fast rule.
That's right. It's not really how the scientific community formally tracks progress.
So in this deep dive, we're going to explore this popular idea, this 7 levels of AI thing you see around, and then sort of compare it with the classifications that researchers actually use.
We've looked at discussions in the tech community, found a YouTuber explaining these levels, and also checked out what AI experts think about this kind of model.
Exactly. The mission today is really to unpack this popular concept, see where it comes from, and figure out what's actually considered standard in the field of AI research.
It's pretty amazing how widespread this 7 levels idea is, though. You find it in articles, blogs, even sometimes in educational resources trying to explain AI's evolution.
Why do you think it's so popular?
Well, I think it's the simplicity. People like clear categories, a nice step-by-step progression. It tells a neat story about AI's journey.
A narrative.
Exactly. Even if that narrative isn't, strictly speaking, scientifically rigorous or universally agreed upon.
And it's not even consistent, is it? We found different versions, like Optimal Dynamics has one take, others bring in the singularity as a level.
That's a key point. There isn't one single agreed-upon list of 7 levels, but typically they start similarly.
Okay, so let's walk through a typical example. Level 1 is usually what? Rule-based systems.
Right. Think deterministic. Input A always gives you output B. No learning, just following preset rules, like a very, very complex flowchart.
The classic example being Deep Blue beating Kasparov.
Precisely. A huge achievement, obviously, but Deep Blue wasn't understanding chess like a person. It was just crunching millions of positions using rules someone programmed into it.
And we see these simpler versions everywhere, right? Thermostats, traffic lights, basic stuff.
Yeah, even some simple recommendation systems fall into this. The big limitation is they can't handle anything unexpected, anything outside their rules.
Okay. Then level 2 in these models is often context awareness. AI starts remembering things.
It retains context from interaction to interaction, maybe learns a bit from patterns, makes things feel smoother.
Like asking Siri or Alexa a follow-up question.
Exactly. They remember what you just asked. Or ChatGPT maintaining a conversation thread. Yeah. Even Netflix learning what you like to watch based on your history.
But it's still pattern matching, fundamentally.
Pretty much. Recognizing statistical links, not demonstrating real comprehension or understanding.
Got it. Level 3 then is often called domain expertise. Superhuman performance, but only in one specific area.
AlphaGo is the poster child for this one, beating the world Go champion.
And Go is vastly more complex than chess, right?
Yeah.
The number of possible moves is astronomical.
It really is. And AlphaGo made moves that top players described as like divine or completely novel. Shows incredible mastery within that domain.
We see this elsewhere too. Medicine, finance.
Yeah, things like IBM's Watson for oncology, trying to analyze medical data, or high-frequency trading algorithms. But again, the key limit is it's stuck in its domain. AlphaGo can't drive a car.
Right. Okay, level 4, reasoning. This sounds like a bigger leap. Analysis, problem solving, maybe even creativity.
This is where current advanced models like GPT-4 fit in, arguably. Solving math problems, analyzing text, generating code, even discussing ethics to some extent.
Autonomous driving systems making real-time decisions would fit here too, I suppose.
You could argue that yes, they're reasoning about their environment constantly, but, and it's a big but, this reasoning is still largely statistical prediction. It's predicting the most likely sequence of words or actions based on vast amounts of data. It can still make mistakes, hallucinate facts. It doesn't have that deep conceptual grasp humans do.
So it's predicting based on patterns, just much, much more complex patterns than level 2.
A good way to think about it.
Okay, then the popular framework usually jumps to level 5. Artificial General Intelligence, AGI. Human-level smarts across the board.
Right. The hypothetical AI that can do any intellectual task a human can. Learn, adapt, reason, solve problems in any field. Sam Altman and others talk about this being potentially closer than we think.
Which would obviously be revolutionary. Robotics, medicine, education, everything changes.
Absolutely. If it's achievable.
And these models often go even further. Level 6, Superintelligence.
Yeah, AI that surpasses human intelligence in basically all aspects. Potentially capable of recursive self-improvement, getting smarter at an accelerating rate, the so-called intelligence explosion.
Which sounds amazing for solving huge problems like climate change or disease.
But also raises massive questions about control and alignment. The alignment problem. How do you ensure superintelligence goals stay aligned with human well-being? It's a huge topic in AI safety. And highly speculative, of course.
And the final step in many of these lists, level 7, the singularity.
Even more speculative. A point where technological growth becomes uncontrollable and irreversible, leading to unforeseeable changes in human civilization.
Kind of like the event horizon of a black hole in physics. You can't predict what's beyond it.
That's one analogy, yes. People talk about human AI merging, maybe transcending biology. It's really out there sci-fi territory for now. Arthur C. Clarke's idea that any sufficiently advanced technology is indistinguishable from magic comes to mind.
Okay, so that's the popular 7 levels picture. Interesting, maybe helpful for visualizing, but as you said, not really the standard scientific framework.
Correct.
So how do scientists and researchers generally classify AI?
There are two main axes generally accepted. One is based on capabilities. That's narrow AI, which is what we have now, AI designed for specific tasks. Then there's general AI, or AGI, the human level goal. And finally, superintelligent AI, surpassing human capabilities.
Narrow, general, superintelligent. Okay.
The other axis is based on functionality, kind of how the AI operates.
How so?
This includes reactive machines like Deep Blue, which only react to current stimuli. Then limited memory AI, which can use past information for a short time, like many current systems. Then theoretically AI with theory of mind, understanding beliefs and intentions. And finally, self-aware AI, having consciousness and self-awareness.
Theory of mind and self-aware AI sound very futuristic.
They absolutely are. We're firmly in the limited memory stage right now, perhaps touching on aspects that look like reasoning.
And experts often just use a simpler distinction too, right?
Right.
Weak versus strong AI.
Yeah, that's very common. Weak AI basically corresponds to narrow AI systems that can act intelligently in specific contexts but lack consciousness or real understanding. Strong AI refers to AGI and potentially beyond AI with genuine intelligence and potentially consciousness, comparable to or exceeding humans.
And just to be crystal clear, strong AI doesn't exist yet.
Not even close. Currently, everything we have is weak AI, however sophisticated it might seem.
So, comparing these frameworks, the capability and functionality classifications seem much more grounded in actual measurable characteristics, whereas the 7 levels feel a bit more narrative-driven and speculative, especially at the higher levels.
I think that's fair. The scientific classifications are more rigorous, less arbitrary. They describe what AI can do and how it works based on current understanding and research directions. The 7 levels are more like a popular roadmap, blending current reality with future speculation.
So, bringing it back to today, based on that popular 7-level model, where would you say we actually are? Somewhere between 2 and 4.
Yeah, I think that's a reasonable placement within that specific model. We have context awareness level 2, strong domain expertise in narrow areas level 3, and we're seeing systems like GPT-4 exhibiting behaviors that look like reasoning level 4, even if the underlying mechanism is sophisticated pattern matching.
But still a long, long way from AGI, let alone the other stuff.
Absolutely. It feels like we're maybe in the very, very early days, like electricity in the 1880s or the internet in the early 1990s. We see the potential, but we're just scratching the surface.
The huge investments pouring in from governments and big tech certainly suggest they believe it's fundamentals.
Undeniably, this isn't just another app. It's seen as a foundational technology shift, potentially on par with the Industrial Revolution or the digital revolution.
So what we have now, impressive as it sometimes seems, is likely just the starting point for things we can't really even imagine yet.
That's the exciting and perhaps daunting prospect.
And for listeners, it means it's definitely not too late to get involved or understand AI's potential. The opportunities are probably still mostly ahead of us.
I'd agree. This is something that's going to reshape how we live, work, and interact with the world in fundamental ways.
Okay, so let's sum up this deep dive then. While that idea of 7 levels of AI is out there and can be a handy way to sort of visualize AI's potential journey, it's really important to remember it's not a scientifically rock-solid framework. It's not universally agreed upon, not an official standard.
The established classifications by capability and functionality, or the simple weak versus strong AI distinction, give a much more accurate picture of where the field actually is and how researchers think about it.
So the 7 steps might be intriguing, maybe useful simplification sometimes, but the reality of AI development is definitely more complex and nuanced.
Well put.
This has been the podcast of Philippe.
If you found this exploration into how we classify AI insightful, please do help us reach 1,000 subscribers.
And maybe a final thought to leave you with. Considering that even popular ways of framing AI's progress are informal, what other tech progressions that seem clear-cut might actually have more complex realities underneath?